All right, so we had left off with going through the different systems within the class Aves. And for those of you who maybe have an opportunity to, I think we talked about this last week, but have an opportunity to maybe hear local news. What is perhaps an issue right now with different agricultural animals, okay, that are grown for various reasons? Who do you think we would start with? Just start thinking of some different types of animals that would be on a farm.
Chicken, cows, pigs.
Okay. Okay. All of those. So what would be significant about chickens right now?
Bird flu.
Yeah, the bird flu, that is the common name. What would the scientific name for that be? Starts with the letter A.
Aves flu.
Close. Avian flu. Okay? Since this is the class Aves, okay, that's why it's referred to as the avian flu. All right? And with that, one of the things that we had left off with, we went through the nerve, or not quite the nervous system yet, but we talked about the circulatory system. Okay? And how is it more advanced than that of their reptilian counterparts?
Their digestion.
Nope, that's okay. We're talking about circulation now. All right. Well,
The chamber of the heart.
okay, yeah. What about it?
For
Yep. Okay. This has there's no separation there between the ventricles, so this is, of course, just a four-chambered heart. And one of the reasons that that's so important is when we start talking about metabolisms from fish, amphibians, and reptiles, that's where you would stop with this type of metabolism. It's a way of referencing the blood as opposed to the class Aves and the class Mammalia. What is significant about, I understand it's red, it's got erythrocytes, it's got, as you can see, phagocytes, but what's it referred to with those three classes of animals, the fish, amphibians, and reptiles? What changes with the birds, mammals, and humans when we talk about blood? Like,
warm-blooded.
exactly, warm-blooded and cold-blooded. So when we're talking about Aves right now, would we refer to them as warm or cold-blooded? Warm-blooded. So they are what we call endothermic. So that means that the heat for their body is produced from within. And in order to do that, is the metabolism low or is it pretty high? It's actually pretty high. And one of the things that we had seen in here in class was, what did we view on public television that had to deal with Alaska? I don't think you were quite here yet in our classroom. But what did we view about these specific animals in Alaska? It was probably 2.5 weeks ago. It's very odd to see these types of animals in a cold climate. So we refer to these as reptiles, but a specific big reptiles would be, of course, there were dinosaurs that were found in Alaska. And the reason that's significant is because it would really, really be tough for a cold-blooded animal to live in Alaska year-round. But it's theorized, and of course this is always changing, that what was true about the outer skin of these dinosaurs. They're starting to grow what? To keep warm. It's very evident in the Archaeopteryx.
Fur.
Not quite fur, that's mammals.
Scales.
Okay, the scales are already there.
Feathers.
Yeah, exactly. They're starting to grow feathers, even in this colder climate in Alaska. Okay, so the respiratory system. As we had said, if they're going to be endothermic or warm-blooded, you have to be able to meet those high energy demands, whether it's for metabolic functions or for muscle contractions. any one of those, you're going to have a very efficient respiratory system because these demands require oxygen and they require nutrients. So the oxygen comes from the respiratory system, of course, which then absorbs, or excuse me, the circulatory system, the blood absorbs the oxygen so it can be transported throughout the rest of the body. Okay, and what we see here, this is unique to the animal kingdom, this right here. Just like reproduction in certain reptiles is unique to those animals, and where their temperature is incubated would determine if it's going to be a male or a female. So this is unique to these animals in that the air doesn't come straight in through, you could say, their nasal cavity or their mouth into a set of lungs. It's actually going to, notice it says air sacs plural, okay? Because there's going to be some air sacs in the front. Those are anterior, and then on the back side is posterior air sacs. And what's unique about this is as this two-cycle system continues to take in air, it's receiving fresh oxygen in its blood when it inhales and when it exhales. And the only reason that that's possible is because of these air sacs, okay? And that will be illustrated and talked about more at a later time. And this, I want to get through this one, and that's it, okay? So this is what we're talking about, this dual cycle, okay? And that is as air is coming in through their nostrils or in through their mouth, it's going to enter the posterior air sacs first. Okay, so what we see happening here, okay, just like in humans, okay, you could say sternum or furcula is actually the scientific name for that as well, because as we maybe have known growing up, it looks very much like this furcula. Let's see here, maybe a box, sort of, and then up about like this, okay? And this is a representation of that furcula or sternum, and that when you would carve a chicken, a turkey, a pheasant, or whatever, two people would maybe grab this, one person this side, one person on that side, and you give it a yank. The wishbone, that's right. So that furcula is that wishbone, and when we say that moves back, is that when those wings go up from the action of supracoracoideus, okay, that pulls the wishbone out, and when the pectoralis comes down, that presses the furcula or sternum in. So what we're seeing happening here, okay, they lower their sternum, and that's from the contraction of the pectoralis, okay? It causes the chest cavity to expand, and it goes into the posterior air sacs first, okay? So the furcula or sternum goes down, it's compressed, air enters the posterior air sacs causing inspiration. Then when you think of a normal expiration, air will enter the posterior air sac, okay, from this inspiration. These two are tied together. Then an expiration, okay, just like when your lungs collapse, but we only have one cycle, these have two. So what we see happening is after they have their wings go up, then this furcula goes back out. This expiration causes the air sacs to compress. Then that air goes into the lungs. Then the next cycle takes place. The next inspiration, where air's coming in, air sacs from the lungs enter the anterior air sacs. Then the next expiration, air will leave through the mouth, okay? Because this is so efficient, and it's explaining because both air sacs fill and empty at the same time. So when this takes place, this bottom point here, birds receive continual oxygen during both inhaling and exhaling. And that's very unique to these animals, which they have to, because we said last week, a lot of these birds do what in the fall and spring? They will migrate, so they actually have to have a very efficient mechanism to deliver that oxygen for such high energy demands. And that's why having nature select these animals to have this structure, the air sacs, that allows them to get air when they're inhaling and when they're exhaling. Again, very, very unique to that of the avian respiratory system. Okay. Does everyone have this content that wants it? Okay. So keep in mind as we look forward the rest of the week, we'll have papers for you on Tuesday or tomorrow. Your first vocabulary evaluation then is on Wednesday. Okay. So your first page of vocab terms, that's what you have on Wednesday. And then perhaps by the time Thursday rolls around, we'll be up to the nervous system. Okay.
Wednesday, we might be a little late to class. We have an exam at 10:10 for our dual credits.
Okay.
Just so you're aware.
Yeah, that's fine.
Is that 9? Yes. My email said 10:10. Let me make sure.
Yeah, that's fine. Just get in here and just get it done. That's all you have to worry about. Okay, so that's all I have. We will catch up to you next time. Papers tomorrow, first vocabulary evaluation on Wednesday. And we'll see about possibly getting out and viewing bald eagles if they're still around. All right.